I'm gonna start.
Good morning, good afternoon, and welcome to our fourth Kraton SBC Inventor webinar, focusing on safe, sustainable, and high-performing solutions for healthcare and sealings and coatings applications. My name is Christopher Schuren, and I will be moderating this session today. Just a few housekeeping items before we begin. All participants have been muted. This session will be recorded and a copy of the recording will be made available after the event. Please use your Q&A button on the right side of your screen to submit any questions you might have. If you are on your mobile, the Q&A button will be on the top of your screen. As part of the agenda, we will start with a brief introduction to Kraton, followed by the technical overview of the healthcare plasticizer-free solutions for better patient safety, and low VOC coatings and sealants design enabled by Kraton styrenic block copolymers. The last 20 minutes or so of this session will be dedicated to address any questions. This session is hosted by our technical experts, Aparajita Bhattacharya and Aaron Brothers. Aparajita has an impressive expertise in new polymer and application development, with a specialized experience in TPE solution development for multi-layer films, medical tubing solutions, and various other healthcare applications. Aaron has a strong skill set in polymer formulations, material characterization, technical service, and application development, delivering innovative solutions for a broad range of end-use markets through collaboration and customer engagement. Kraton is a global leading producer of specialty chemicals. We develop, manufacture, and market styrenic block copolymers and bio-based chemicals. Headquartered in Houston, Texas, Kraton has a global manufacturing and operations footprint with over 1,800 employees. Kraton's commitment to sustainability has been recently recognized with the EcoVadis Platinum Sustainability Rating, and Kraton is also a proud member of the Association of Plastics Recyclers in North America and Together for Sustainability initiative. Our 13 manufacturing plants, 9 innovation centers, and multiple regional offices enable us to deliver sustainable solutions globally. For 64 years, Kraton styrenic block copolymer solutions have been helping our customers to address key industry challenges by enhancing sustainability and circular economy through unique performance enhancement functionality, multi-resin compatibility, and processing versatility across a wide range of applications. In the recent years, we have been observing an increased focus on safety and sustainability within the healthcare market, driven by patient safety, regulatory changes, and need for sustainable design. Regarding patient safety, an increased concern with the use of plasticizers has been witnessed. According to the National Institute of Environmental Health Sciences, migration of plasticizer may have a negative effect as phthalates are known to interfere with the body's mechanism for hormone production. Increasing regulations around the use of plasticizers for IV administration, especially to infants and elderly care, have been observed, in addition to the increasing concerns linked to the release of dioxins from incineration of PVC-based materials. In terms of sustainable design, the waste stream of medical disposable devices was inherently incinerated. However, there is an increased interest in reusing the recycling stream in the recent years. At Kraton, quality is the key priority in every aspect of our work. Our polymer solutions are geared towards the medical industry by ensuring a continuity of supply with multiple manufacturing locations globally, a high level of product consistency ensured by our manufacturing processes, And given stringent medical requirements, we are very careful in selecting the raw materials and additives for our solutions. Having an effective change management procedure in place to allow efficient communication, a shelf life up to 5 years, and our products are tested to meet stringent requirements for medical applications in compliance with US Pharmacopoeia, FDA, and ISO 10993. Also, extractable and toxicology profiles are available. For more than 3 decades, the medical community has entrusted and relied on Kraton to deliver the highest level of quality, and we are committed to meeting those expectations. So without further ado, I'm handing over to Aparajita to discuss our healthcare solutions in more detail.
Thank you, Christoph. So as Christoph just mentioned, Kraton has been a reliable source for high quality polymers in the healthcare sector. Kraton's polymer solutions are used extensively in several areas of the healthcare market. For example, in medical films, like in IV bag systems, ostomy bags, blood bags, etc. In medical tubing applications, where you can imagine a whole tubing, a whole set which requires a lot of tubing, for example, IV tubing, biopharmaceutical tubing, in medical stopper applications, in all kinds of IV stoppers, vial stoppers, and needle shields, and in IV bottles. Now, these are just some of the examples where our polymers are being used today. In this presentation, I will go into details on specifically the medical films and medical tubing applications. So Kraton offers a range of polymer grades with properties that lend themselves to the key features of medical films, used, for example, in an IV bag application. Use of Kraton polymers enables the elimination of plasticizers and hence a phthalate and plasticizer-free formulation design that translates to enhanced patient safety. Medical films with Kraton polymers exhibit excellent mechanical and optical property retention even after sterilization. This leads to superior end product performance. Compatibility between polyolefins and several grades of our polymers leads to very low haze and high transmittance, which provides the benefit of almost glass-like transparency and clarity. Adding Kraton grades to medical film formulations lead to improvement in seal strength and impact properties, thus allowing the end product to meet performance and regulatory requirements. And finally, since our solutions are based on the blends of polyolefin and thermoplastic polymers like styrenic blockopolymers, it definitely helps towards recycling after use. Here we present an example of medical films in an IV bag application. A typical 3-layer IV bag structure is shown here, where each layer is composed of a Kraton SCBS and polyolefin. In this example specifically, we have prepared films using the Kraton grade G1645 blended with polypropylene. The type of polypropylene, for example, if it's homo or random copolymer polypropylene, was selected based on which layer it was going into. The total thickness of this film was 180 microns, which is a typical film thickness in this application. We studied the effect of varying the amount of G1645 in the inner sealing layer, as well as in the middle layer, on 2 properties that we have shown you here, such as the seal strength and the drop dot impact resistance. In both these data sets shown here, the amount of G1645 in the sealing layer was varied between 0%, 10%, and 20%. And they are shown by the blue bars, yellow bars, and the green bars respectively. And for both of these graphs, you can also see the G1645 in the middle layer is shown as the x-axis, where the amount of the polymer in the middle layer was varied from 10 to 75%. So if we now look first at the plot for seal strength, it can be seen that the seal strength it increases as the amount of G1645 in the inner sealing layer increases. Um, and you can see this across the entire x-axis, which is the G1645 in middle layer, where it was increased from 10 to 75%. The data on drop dart impact was collected by dropping weights from a height of 1.5 meters. First of all, it can be seen from this data that increasing G1645 in the sealing layer does have a positive impact on drop dart impact resistance of the entire film performance. And you can see that the impact resistance increases systematically with an increase in G1645 in the sealing layer. What we can also see is that as a function of G1645 in the middle layer, we can see that beyond 25% addition of G1645, the bags really don't undergo breakage even after the maximum weight of 2.1 kg was reached. So these two data sets together show that 10 to 20% G1645 in the inner sealing layer significantly improves the seal strength, and 25 to 50% loading of G1645 in the middle layer highly improves drop dart impact performance. Here we have further data on optical properties of the films made using G1645 and polypropylene. The polymer microstructure of G1645 allows for excellent compatibility with polypropylene, and this results in very fine dispersion in the final blend. So the data here shows that the transmittance increases systematically as the amount of G1645 in the middle layer is increased. And here we have shown you the data with 10% G1645 in the middle layer, but it really is holds for all compositions, all loading levels of G1645 in the sealing layer. We can also see the opposite trend with respect to haze, where haze decreases systematically as you increase the amount of G1645. So G1645 is our workhorse grade in medical film applications. However, we also have other commercially available grades that may be more suited to your process and more suited to meet the specific requirements of your application. And of course, we can discuss them if you're interested on a one-on-one basis. Here we show you an example of how Kraton polymers can assist in providing solutions to specific application problems. There are OEMs who express interest in switching from PVC to thermoplastic elastomers in IV bag films. They want to be proactive in having a phthalate-free solution in anticipation of upcoming regulatory changes. One of the Kraton solutions is to use G1645 polymer, which is blended with polypropylene. And films from such a compound can be made using either a cast film extrusion or a multi-layer blown film extrusion process. The value that the customer sees from this Kraton solution are that the IV films are then phthalate and plasticizer free, and as they can meet the mechanical and optical property requirements very well before and after sterilization. So in the next few slides, I will talk about medical tubing application and go over some related data. Our polymer grades suitable for medical tubing show key features and benefits that are similar to those that you saw for IV film application, like, for example, enabling plasticizer-free formulations, excellent mechanical and optical properties that enhance patient safety and compliance with stringent requirements for the medical tubing application itself. And additionally, Use of our polymers in medical tubing leads to a balance between stiffness and flexibility of the tubing that translates into excellent tubing kink resistance. Our solutions allows for solvent bonding using the most common types of solvents like THF, cyclohexanone, or methyl ethyl ketone. Um, the tubing also exhibits good elasticity with low hysteresis that helps in consistent flow performance in applications where long-term flow is important. And again, similar to the case of IV bags, for example, formulations prepared with the Kraton polymer solution for medical tubing are amenable for recycling after use and has easy end-of-life management. Here we present an example of Kraton SEBS and polypropylene blends in medical tubing application. The ratio of SEBS to polypropylene really depends on the hardness requirement of the final tubing, and it can vary from 70-30, for example, in an IV tubing application, to about 80-20 or 88-12, for instance, in a peristaltic pump application. In this table, we have shown a comparison of the tubing properties made with G1645 and polypropylene blends at 3 different ratios, and also performed the same tests on a silicone tubing. It can be seen from the decreasing shore A hardness here, and the model is that the G1645 polypropylene tubes become softer with increase in G1645 SEBS. So you can really tailor the hardness by varying the proportions. Tensile strength decreases slightly, while ultimate elongation is well above 900% for all the G1645 polypropylene compositions. And what we can also see is that the modulus of these tube is quite similar to that of silicone tubing. In tubing application, kink diameter becomes very important. And here we can see that the apparent kink diameter of G1645 polypropylene blends is quite low. You may know that silicone has poor kink properties, and the G1645 polypropylene blend shows really improved kink resistance over silicone. For specifically for peristaltic pump application, consistency of flow over time is an important criteria. It may be an important criteria in other systems where tubing is used for long-term flow also. We measured the flow rate. So here we performed flow consistency tests using a peristaltic pump, and we have shown the test conditions right here. We measured the flow rate before and after an 8-hour flow period, and we measured the change in flow rate. Flow rate, you can see that the flow rate change is very small, and it definitely depends on the tubing hardness, which depends on the tubing composition, but it is much smaller than the change that is seen in a silicone tubing, for example. And what we can see from all of this data is that apart from good kink resistance and high consistency of flow, the Kraton G1645 polypropylene tubing will also provide excellent transparency to medical tubing. We have not shown the optical properties in this table, but it has been measured. And again, similar to medical films, while G1645 is the most widely used Kraton grade in medical tubing application, we can definitely recommend other grades depending upon your specific process needs and required properties. Here we have shown data on kink resistance and solvent bonding of G1645 polypropylene blend, along with a new polymer grade that we developed specifically for tubing applications. As you can see, this development grade shows excellent kink resistance, which is really at par with that of PVC. As for solvent bonding, we perform the tests with 2 types of connectors, one where the outer surface of tubing is in contact with the inner surface of the connector, such as this one. And the other is this type of connector where the inner surface of the tubing is in contact with the outer surface of the connector. So what you can see from this data is that the bond strength depends significantly on the type of connector being used. For example, for this kind of a connector where um, greater surface of the tubing and connector are in contact to begin with, you definitely see higher bond strengths. In this, so having said that, you can see from this data set that the development grade shows somewhat higher bond strength as compared to G1645 PP blends. Here we show you an example where Kraton solutions can be used to replace silicone in tubing applications. You saw all of the data just a couple of slides ago. Silicone tubing, as I said before, shows poor kink resistance, and being a thermoset elastomer, it involves more steps in compounding and extruding. These are some of the main reasons why customers are interested in replacing silicone with a TPE solution. And the good news is that Kraton does have a solution in the form of a blend of our G1646 polymer with polypropylene. Tubing made with this blend meets the performance requirements. It is easy to process. It shows improved kink resistance over silicone. Additionally, it also shows better consistency of fluid flow over a long period of time than silicone, and it has an overall improved system cost. Now, we really come back to the fact, as Christoph mentioned at the beginning, that in recent years, the focus of healthcare industry has been on safety and sustainability of the products that are being used in this market, that is driven primarily by patient safety, regulatory changes, and the need for sustainable design. And through this presentation, we have provided data and examples of how Kraton polymers enable solutions that touch upon all three focus areas. So essentially, a Kraton polymers-based solution will help you to make a plasticizer-free, low VOC formulation with lower leachables and extractables profile and improved drug compatibility. By enabling phthalate and PVC-free products, our solutions help in reducing the adverse impact on environment and complying with existing and anticipated regulations, along with addressing regional healthcare regulations, for example, around DEHP concerns. And finally, a Kraton TPE-based solution allows for a fully recyclable and sustainable design due to lightweighting and due to easier management of end-of-life disposal. At this point, I'll hand over the presentation to Aaron, who will take you through Kraton solutions for low VOC coatings and sealant products. Aaron?
Thank you, Aparajita. So in this portion of the webinar, as we mentioned, we'll cover the innovative solutions for the low VOC coatings and sealant formulations. And Kraton has decades of experience in innovation and growth in this area, and many of our products are part of your daily life. So we recognize a need for high performance and efficient systems that utilize high solids in industry that's typically looking for low environmental impact and sustainable designs, and the market appears to stay strong due to building and construction growth. Now, new materials help drive market trends, but these are not without challenges. For example, some systems with 100% solids, such as silicones and modified silane polymers, also known as MS polymers, may have little to no shrinkage, but they can be expensive, difficult to color match, or they may fail through crack propagation. Some materials may also have shelf life limitations and can be difficult to apply during dry or humid conditions. Therefore, industry requires flexible strategies in order to meet today's demands while keeping approaches friendly to the environment in mind. Reducing volatile organic compounds, or VOCs, are also paramount for sustainability and for product growth. So Kraton brings value design with new products that help achieve the balance between performance and efficiency. Meeting the needs of today's challenges requires innovation and expertise in order to design new systems that are sustainable and flexible for the environment. For instance, water-based systems may be more cost-effective and environmentally friendly, but generally have poor water resistance and application challenges in weather extremes, such as in sub-zero temperatures. Hot melt-based styrenic block copolymer or SBC systems have formulation flexibility, and they can be cost-effective, but uses may be limited to those that have the ability or the special equipment in order to apply the hot melt-based systems. Solvent-based systems can be exceptionally clear and very weather resistant, but are then challenged by VOC regulations as well as health and safety concerns. Regulatory pressure can then reduce VOC limits in different regions within a given industry, and technical solutions are then needed to help formulators drive the VOC components down for their formulations without compromising the material performance. Therefore, Kraton offers new low-viscosity SBCs that may be used to reduce VOCs in adhesive, sealant, and coating applications. Our polymer products can be found in numerous applications due to their high performance characteristics and formulation flexibility. Kraton polymers include unhydrogenated SBCs, also known as USBCs, as well as hydrogenated SBCs, or what we call HSBCs. These products have been useful for many applications, such as those found in these market segments, as their unique chemistries provide great strength, elasticity, and compatibility with present and future materials. Other examples of applications that may benefit from this technology may include those such as concrete coatings, construction sealants and adhesives, UV resistant coatings for the transportation sectors, for example, roof coatings, waterproof coatings, maybe packaging adhesives, cross-linkable systems, and other consumer or industrial applications. Kraton HSBCs offer several key performance features, such as low toxicity, superior flexibility, great UV and ozone resistance, good adhesion to several different kinds of substrates, including during wet conditions. They have a strong resistance to acids and bases, as well as salt water and salt spray. And they can also be formulated either clear or for pigmented applications. These features can then lead to benefits such as excellent weather resistance and long coating life, flexibility and resistance to chips and cracks, also the ability to withstand expansion and contraction cycles. They can be formulated for personalized aesthetics and potential to reduce the recoat application costs, so labor costs. So several of these benefits are useful to help ensure long-lasting performance. Kraton's precisely controlled anionic chemistry allows molecular adjustments to make smaller molecules, which improves processing and leverages lower viscosity in the application, which can then be utilized to potentially reduce VOCs in the formulation. For example, one of our new polymer grades, Kraton G1653, highlighted here, is a low viscosity, high melt flow SEBS product. It may be of particular interest to solvent and hot melt based systems because the lower viscosity and higher melt flow enables easier processing and may offer the potential to reduce cycle times. G1653 may also be used with some exempt solvent systems to help meet regulatory standards and enable VOC reduction through that route as well. It is easy to mix and extrude and may offer formulations with higher solids content, which in turn may reduce solvent usage. It also has other key features such as having a low TG and is available in the form of dense pellets, which enables easier handling compared to other product forms such as polymer crumbs. Several other potential applications are highlighted here, but there may be others that are well suited to yourself as well too. The operating box for Kraton products are wide, and they can be formulated to the application needs. Here, we have an example in which our low viscosity grades may allow greater formulation flexibility compared to other traditional SEBS products, such as G1652. Two knobs can be turned to achieve performance attributes. So in this example, we have A, the polymer concentration can be maintained at, say, 30%, but then the viscosity can be lowered when we use a lower viscosity grade, such as G1653. The lower viscosity may lead to lower pressures, which may also reduce cycle times or reduce operating system costs. But then we also have a second knob B, so we could maintain viscosity to increase the solid's concentration. So in this case, we're taking G1652 from 25%, and when we swap out with G1653, we may be able to increase our solids up to 30% while still keeping similar viscosity. So this lowers the amount of solvent used and will result in less VOCs in the application coating. Here, G1726 is used only as a reference for illustrative purposes, since it also has low viscosity, but realizing the strength and flexibility is not necessarily the same as that of G1652 or G1653. Next, we have a rheology plot that reflects the step changes in viscosity and shear rate between both G1652 and then a lower melt viscosity product such as G1653. So typically lower viscosity at higher shear rates are preferred and may offer potential energy savings due to less energy input needed to mix the low viscosity products. So on the previous slide, we were looking at a solvent-based system, and on this particular slide, this is a hot melt-based system. So in this case, G1652 has a melt flow rate of 2, while the lower viscosity or the higher melt flow product of 1653 is closer to 27. So smaller molecule designs and lower viscosities may also be leveraged to lower application temperatures for hot melt-based adhesives, for example, or other hot melt-based processes. This reduces the oxidation and degradation that may occur at higher processing temperatures. So for example, in the personal care application, the effects of reducing the basis weight of the materials or making products thinner may now be more sensitive to application temperatures for hot melt-based systems. So in this case, the low viscosity of G1653, again the blue line, was leveraged to reduce the application temperature some 30 degrees Celsius, as can be seen in this graph on the right, compared to a G1652 based material. The hot melt adhesive properties on the left were still somewhat similar between polymers, with some slight exceptions around ring and ball softening point and shaft. But in this case, additional formulation techniques may be used to further optimize those properties as well. So here we have more examples of potential applications and the benefits of using Kraton HSBCs. They help provide weatherability, low temperature resistance, long service life, and have high strength and flexibility. In sealants and coatings, for example, other benefits may include the ability to reduce shrinkage, to bond to wet surfaces, and enable lower VOC content or possibly system cost savings. Kraton MD1648 is another new molecule in the HSBC family. This grade has very low viscosity and a high melt flow and has excellent compatibility with polyolefins and non-polar substrates. So because it has such a low viscosity, it may also be of particular interest to formulators. So here, the low viscosity and high melt flow may enable easier processing and the potential to reduce cycle times and generate additional formulation flexibility, particularly around VOC content. So again, we list several potential applications, some of the medical applications that Parajita mentioned. In this case, we have the sealant and coatings applications, but there may be other applications that you find interesting as well too. So with sealants and coatings, we have a comparison of a reference HSBC and MD1648 as designated in the top blue row. So here we have xylene and PCBTF, which is a VOC exempt solvent, and this is located in the far left column. The center dark and light gray boxes illustrate the solution viscosities in the system for a given polymer loading level and for the VOC solvent ratio. So for example, the number circled in green on the far lower right of the table is the solution viscosity of MD1648 at a concentration of 25 weight percent polymer in a solvent that consists of PCBTF and contains no other solvent, in this case 0% xylene. So here the viscosity is noted as only 755 centipoise, which is extremely low when you're thinking about the 25% polymer content in a VOC exempt solvent, which typically have higher viscosities than VOC containing solvents. And we compare this to a reference HSBC formulation. That reference sample has a viscosity above 50,000 centipoise. So therefore, some of these products, such as MD1648, may enable even lower VOC content reduction due to their significantly low viscosities. In this study, we illustrated improvements in VOC reduction by utilizing Kraton G1653 and MD1648 and comparing to another HSBC-based formula. So we made a basic sealant formulations that contained Kraton HSBCs, tachifying resins, AO, and a solvent system in the table on the right. We then calculated VOC content for each formulation, and we did that just by utilizing a basic formula that's readily available online. In this case, we received the formula from the South Coast Air Quality Management District, as shown here. And we then measured vertical slump resistance at room temperature just for screening purposes. So on our lab study, we found that Kraton products, such as G1653 and MD1648, allowed lower VOC content when we compared them to a reference sample by enabling an increase in solids content and the ability to incorporate the VOC exempt solvents. So on this slide, we have the table below, and we're going to look at S-1, which was our reference sample made at 70% solids with a calculated VOC of 288 grams per liter. This sample also had 0 slump at room temperature during testing. We then replaced one of the HSBC polymers in the reference sample with G1653 in a 1-to-1 substitution. This brought the formulation viscosity too low, however, and the sample ran down the vertical channel, creating a significant slump value. Therefore, we reformulated to increase the total solids content by 10%. This put us at 80% solids, as can be seen in sample S-8, to boost the viscosity back up, and then we again improved the slump resistance back to the similar test results that we received for the reference sample. We left the types and ratios of all the other ingredients the same in this case, and we were able to effectively drop the VOC below 200 grams per liter to 195. So that's a 30% decrease in VOC by simply removing some of the solvents. We then performed the same action with MD1648 and yielded similar results due to the benefits that these lower viscosity grades provided. So next, we substituted some of the VOC containing solvent for a VOC exempt solvent, but needed to drop the solids content back down to 70%. So again, that was to offset the higher viscosity that was caused by the VOC exempt solvent. However, the effect of the VOC exempt solvent outweighed, in this case, the initial solvent reduction from the calculation. So we were able to achieve even lower VOC contents down to 78 grams per liter for G1653 and near 0 for MD1648, which contained strictly VOC exempt solvent and no VOC containing solvents such as xylene or toluene. So we didn't have any of that for the 1648. And the lower viscosity 1648 utilized, again, all VOC exempt solvents. So here we have S-19 and S-20. And the picture on the right illustrates the slump samples. And although samples S-19 and S-20 had slightly higher slump, they were less than 1, whereas the other ones measured basically 0. One may be able to reformulate around this and increase the slump back up. So for instance, we could have possibly increased the solids content back up, say 3 to 5%. So still keep a manageable viscosity, but then improve your slump resistance back to the reference sample. So it should also be noted that the VOC content may be measured or calculated differently for the different regions or market segments, and that should be taken into account for your situation accordingly. Okay, I hope you're still with us and hanging in there as we're getting close to the end. I would like to highlight a couple case studies in which Kraton products have enabled value creation. So this example is very similar to the sealant example that we just walked through, in that the low viscosity Kraton G1653 enabled a higher solids content in construction and DIY sealant and coating formulations, which then allowed lower VOC content and reduced the shrinkage of the final product. Kraton G1653 was designed to be compatible with other raw ingredients commonly used in this industry. And Kraton HSBCs also provide the ability for a customer to utilize reflective roof coatings in broader weather conditions, which compared to other chemistries may result in more days of work for installers and less dryer cure time. Think of wet and cold environments, for instance, and the potential downtime that could be saved when a product can be applied regardless of the weather conditions. Next, another example was utilizing a low viscosity Kraton SEBS in a sprayable automotive coating. So spray applications typically require very low viscosity and may be limited by the materials that can be spray applied. When solid contents are low due to viscosity limitations of the raw materials, the application may require a greater number of coats in order to maintain the desired film thickness or achieve the desired film thickness and the properties. So with lower viscosity Kraton products, the solids content was slightly increased, which then reduced the amount of coatings needed on the automobiles, which resulted in a VOC reduction and a decreased total application time. Removable or strippable coatings can also be used for protection and customization in today's personalized world. Easier processing with no residue may also allow for fewer hours per application, and so a total system cost savings for the end-use consumer or customer may be realized. So to sum it all up, Kraton has the experience and commitment to provide innovative products for an ever-changing world. We value sustainability, innovation, and the customer and technology base, and we greatly appreciate all of the opportunities we have had over the years in successfully supporting its numerous market segments. Kraton polymers allow enhanced processability, formulation flexibility, improved performance, and can fit many end-use applications. Many of our products have FDA clearances, they can be recycled, and they may also enable system cost savings. We hope that you found this webinar useful and potentially sparked at least some interest for new and unique solutions. With that, this concludes our presentation part of the webinar, and I will give it back over to Christoph to move into our Q&A session. Thank you.
Thank you, Aaron and Aparajita, for the great presentations. We did receive several questions regarding both topics, so let's try with the time that we have remaining here to address as many questions as we can. So first question that we have here, are there, and I assume, Aparajita, this one is for you as it's related to healthcare, are there any issues or phase separations with blending an ERS polymer with a standard SEBS grade? So an example would be the MD1648 with G1652. So again, I'll repeat, are there any issues, phase separation when blending an ERS with a standard SEBS grade?
There could be, there should not be any phase separation issues as such. They should blend well together, but the refractive index can change, which can affect your optical properties. And it really depends also on how well you are matching the melt flows of the polymer grades that you are choosing. So typically ERS grades have higher melt flow than some of our other classic grades, Kraton grades. You would need to definitely add oil into those grades to match the melt flow with some of the ERS grades. But as far as phase separation, I don't think that should occur. The rubber mid block should blend very well.
Okay, thank you, Aparajita. Next question, also geared towards the healthcare presentation. What was the maximum pressure which the peristaltic tubing was able to reach? So what was the maximum pressure which the peristaltic tubing was able to reach?
I would have to get back on that question. I don't have it at the top of my mind. I have to dig into the data a little bit more to answer that. So, Christoph, if you can make a note and we can get back to the person who has this question.
Yes, we can. This was posted anonymously, but you will see our contact details at the in the slide that you have in front of you. So please, if you can get back to us, either to Aparajita or myself regarding that question, we will get back to you. So I'll follow up on other questions. I think this one is geared towards you, Aaron. What are the differences between MD1648 and G1653?
So the primary differences between those two are the MD1648 is an ERS polymer, so it's what we call an enhanced rubber segment polymer. So the structure in the rubber block is slightly different than what we would have in G1653, which is a typical SEBS polymer. So the microstructure is a little bit different between the two. There's some molecular weight differences between the two as well. So those are really and the polystyrene content, I believe, is also slightly different too. It's slightly lower on the MD1648. So MD1648 would have a much higher melt flow or lower solution viscosity compared to G1653.
Okay, thank you, Aaron. I think the next one is also for you. This is a lengthy one. With the toxicity problems we are seeing in California and potential removal of PCBTF as a VOC exempt solvent as well in California, are there any other VOC exempt solvents that can work as an attractive solvent or diluent to Kraton G solvent-based coatings and sealants?
Yep, so that's this is a great question and one that we get probably quite often. So there are a few other VOC exempt solvents. One of those that's probably the next most compatible with our polymers would be tertiary butyl acetate. Sometimes acetone's also considered a VOC exempt solvent, although it's extremely polar, and so a lot of times we find that we'll have to mix the different solvent systems in order to get the compatibility we need. So if you just take acetone, for example, none of our polymers will dissolve in acetone, at least none of our base polymers that we talked about today. But sometimes you can fit in, say, 3 to 5% of your solvent portion of your formulation, and that could contain 3 to 5% acetone, for instance. So we would have to play around, but really tertiary butyl acetate's the next best one. And there may be a few others, some of the acetates, but I have to check. But yeah, I would recommend tertiary butyl acetate would be the next best one after PCBTF.
Okay, thank you, Aaron. Following question, this goes back to healthcare. Which method did you use to measure kink resistance? Aparajita, I think.
Yeah. Oh, okay. So actually, there is not one method to measure kink resistance. From what we have heard from our customers, they develop the methods on their own. It's their specific method, and it ranges from measuring kink resistance using a hand method to measuring kink resistance using a more sophisticated instrumented method. So we developed a method in-house based on voice of the customer and what we thought would be relevant. In this method, we take a U-shaped a tubing segment and we put it in between the grips of an Instron-like tensile testing machine, for example. And the distance between we have a certain distance between the grips, and then we start to deform or move the upper grip down, so lower, and the distance at which the tubing kinks is what we consider as the kink diameter.
Thank you, Aparajita. Next question is, I think, also for you. What type of antioxidants are used in medical applications with the Kraton products? How do they make sure nothing leaches out into medications?
So the antioxidants that we use are primarily meant for our polymers to have, first of all, go through the finishing processes, and secondly, to have the shelf life that we claim the polymer will have, which Christoph mentioned in the beginning. It has 5 years of shelf life. So we add minimal antioxidants from our side into our polymers. When you are using our polymer in your application, it is your responsibility to ensure that the antioxidant type and amount that you are using are aligned with the regulatory requirements, and that it will be able to pass the leachables and extractable studies. Um, what I can tell you from the antioxidants that we use are typically your Ergonox 1010 type of antioxidants in most cases. It can vary in some cases, depending on the polymer that you're receiving.
Thank you, Aparajita. Following question, and questions are coming in, so we might not have sufficient time to answer them all. If not, we will definitely come back to the person that asked that specific question with some more feedback. So next question, I assume, Aaron, this is for you. Can Kraton products G1653, MD1648 be used to make a lower VOC hybrid sealant by modifying a silicone sealant?
Yeah, that's another good question. That'd have to be tested specifically, but I would guess probably not, as the compatibility between G1653 and MD1648, they're just not very compatible with the silicone systems. So yeah, creating a hybrid type sealant with our products, again, that would have to be something that I guess would have to be tested. But I think the likelihood of that being successful is relatively low, just due to the compatibility differences.
Okay, thanks, Aaron. I think also the next question is to you. Can Kraton polymers adhere to metal and other polar substrates?
Yes, so typically we have a lot of our functionalized G grades for that. So it's FG, for instance, FG 1901. So our functionalized grades do have great adhesion to a metal substrate. So if a sealant or coating or adhesive even were to go onto a metal substrate, we would highly recommend a small percentage to add of, say, either one of our FG products. And usually the loading levels are anywhere from 1 to 5%, depending on the application. So by themselves, 1654 and MD1648, for example, in these, they may have some adhesion, but it's not going to be much. But we can certainly blend our products, or the customer, you can certainly blend our products. And with some of our functionalized grades, you can certainly have great bonding to metal and polar substrates.
Okay, thank you, Aaron. Next question. This is related to medical, but I think I can answer this one. What is the grade name code for the tube development grade, which can be solvent bonded with THF? I can take that, Aparajita. So this was not anonymously posted. So the person that posted this question, we will come back to you with specific information regarding what we presented here today. So we'll not divulge this information here in this event, but for sure we'll follow up. As another question for that was entered here, what kind, and again, Aparajita, I believe this is medical related, what kind of regulatory tests have you performed on your polymers?
I think, Christoph, you mentioned in the beginning itself that our polymers are FDA approved and pharmacopoeia compliant. So we have performed we perform typically USP testing or ISO testing data, and we have that data on several of our polymer grades, and especially for those used in medical applications. And if you are interested in receiving some of the data or evaluating any of our grades, and you would like to see that data, we definitely can provide you with more information. And yeah, just contact us and we can take this discussion offline.
Okay, thanks, Aparajita. Another question, Aaron, this is, I assume, geared towards you. Can we use SEBS in hot melt thermoplastic with rosin ester combination?
Yes, so the answer is it really depends on the formulation, the application, but usually we can get things like that into the system by using either some of our other products as compatibilizers, or using other additives as compatibilizers. So yes, again, it depends on the application specifically. Some applications may run into compatibility issues while others cannot, and it depends on the exact rosin ester as well too. But yeah, for the most part, I would say it depends, but it's definitely doable.
Okay, thanks, Aaron. Another question, I assume, Aaron, for you. Has Kraton been as a modifier for TPO sheet goods? If so, follow-up question, could the Kraton improve the adhesion capability of TPO?
So they can, yep, and typically it would be the, and it depends what kind of adhesion levels need it, right? So yes, they can improve the adhesion levels certainly, and then depend on if there's additional adhesion needed, then you would simply add a tackifier or something like that in to improve the adhesion even greater. But usually that's where like MD1648, some of our G1640 series would be good for those type of applications.
Okay, thank you, Aaron. We're getting close to the end of the session, and still we have a couple of more questions to go through. So here's one, I guess, Aparajita, related to healthcare. How are the mechanical properties affected in IV film applications by the addition of polypropylene in the formulation?
Good question, Christoph. So that is one thing that we did not show in as data in our presentation, but we definitely have measured the mechanical properties, and we can share if needed. And what we have seen is that the addition of polypropylene, it increases the tensile strength, while keeping the elongations the same. And the elongation is typically greater than 700% for all blend ratios. And we've also seen that by using our G1645 type of grade, for example, the films do remain isotropic, so similar mechanical properties in machine and cross directions.
Okay, thanks, Aparajita. I think we have time for one more question, Aaron. I think this is towards you. It's a cost question that always comes up. Would the performance versus cost give enough value to choose this solution in coatings versus water-based or lower VOC solvent content? Can you address that, Aaron?
Yeah, so that answer is going to be it depends, right? What is the customer looking for with respect to both performance and cost? Is there enough value there? Sure, there's situations where there are, and then there's probably situations where there's not. So unfortunately, I can't give an answer other than it really depends on the specific application.
Okay, thank you, Aaron. I think that we're running into the end of this session. In order not to move over the time that we allocated for this, we will come back to the specific questions that have not been answered. I do realize there's a couple of them that we have not touched upon, but in lieu of time, I think we need to close this session here for today. I would like to thank you all again for your attendance and also for all the great questions. And we for sure will circle back to you with the answers to those specific questions. In the meantime, please do not hesitate to contact us if you have any further related inquiries. And with this, I will close the session for today and hope to talk to you soon. Bye for now, and thanks for attending.